In this video we're going to learn about something called Cramer's rule. And throughout this unit we've learned several different methods to solve systems of equations. We've learned how to solve them by graphing, how to solve them by substitution, and then how to solve them by elimination. This is actually method number 4. It's a fourth different way that you can use to solve systems of equations like the ones that you see written right there. So this is called Cramer's rule, and in just a sec I'm going to show you how to use it. First thing we have to realize though is this only works when there's one solution. So earlier in the unit I drew 3 graphs, and here's what they look like. These are just coordinate axes right here. The first graph would have, let's say, 2 parallel lines, and that's a case where you have no solutions. The second graph would be a line and then another line right on top of it, and that would be infinite solutions. So let me just mark that. This is no solutions. This right here is infinite solutions. And the third and final case is when you just have one solution. So that would be, there's a line right there, and there's another line, and they meet right at that point right there. And really these should have arrows on it to indicate that they keep going. But the point is that Cramer's rule is only going to work for case C right there when you have one solution. I'll show you an example of what happens when it doesn't work, or how you can notice that. But here's the procedure. 2 main steps. We have to find 3 different determinants, and we learned how to find determinants in the last video, so we'll recap that. And then secondly, we have to find the x-coordinate by taking one of those determinants, which is the determinant for the x values. It's called d with that little x right there, dx. And we divide it by big D. Big D is the determinant of the whole system. And then same thing for the y. To find the y coordinate, we take the y determinant, which is dy, and we divide by big D, the main determinant. So let me show you how to do that right now. So first of all, to find the main determinant, you do the following. This would be our x column, this would be our y column. To find the main determinant, what numbers that go in here are basically the coefficients of this system. So -3, -3, you can see would be the first x and the first y, -3, -3. And the bottom, this is a 1x right here. Bottom is going to go 1 and 2. So where did those numbers come from? They came from this system right here, from the coefficients in front of x and y. And I made a column for x and a column for y. And that's how we find the determinant, big D. So how do you find the determinant again? What we need to do is multiply the diagonals. So we're going to have, we will have -3 times 2, which is -6. It's always minus. And then we have 1 times -3 is -3. So we have -6 minus -3, which is like -6 plus 3. And that equals -3. So I'm going to circle that because that's our first determinant. Okay, the next thing we need to do is I'm just going to move this down so we have a bit more space, is we need to find those other 2 determinants I mentioned. We need to find d sub x and d sub y. So how do you do that? It's almost the same, it's just a slight catch. Okay, so here's our dx determinant. And here's the only difference. The y's are going to stay exactly the same because we're not trying to find the y determinant. We're trying to find the x one. Instead of putting -3 and 1 in the x column like we did for regular determinant, for regular big D, we're going to replace that column with the answers to this system, with 27 and -14. So again, we're trying to find the x determinant, so the x column is what gets replaced with the answers. And there is a proof. It's a fairly complicated proof, or at least many in linear algebra are certainly more complicated than what's within the scope of this course. But there's a proof about why this works. In Algebra 2 course, you're not really expected to know that proof. If you are interested, you can certainly search it. But in this case, all we need to know is that to replace the x column with the answers 27 and -14, and that will give us this thing right here, the dx. So now we find the determinant. 27 times 2 is 54, minus -3 times -14 is positive 42. So 54 minus 42 equals 12, and that's our dx. Last one we need to find is the dy. So it's going to be the same, and you might be able to guess. Pause it and try to think about what's going to go in that number. Okay, but here's basically what we're going to do. We're finding the dy, so the x column is going to be -3, 1, just like it was at the start. This time we're not going to put -3, 2 in the y column. We're trying to find the y determinant right here, dy. So we'll replace it with these numbers, with the answers to the system, 27 and -14. Okay, the determinant of this, -3 times -14 is 42, minus, and then 1 times 27 is 27. 42 minus 27, that equals 15. And now there's one more step, and that's an easier step than what we've done so far. The last step is to find this number and this number. So the x solution to this system is dx over d. We found out that dx is 12 and d is negative 3, so 12 divided by negative 3 is negative 4. The y solution is dy over d. dy we found up here was equal to 15. Big D again is negative 3. 15 divided by negative 3 is negative 5. So our solution, our final answer to this question, x comma y, would be negative 4 comma negative 5. And if you try to solve that system using any of the other methods we've learned, elimination, substitution, and so on, you'll get the exact same answer. So give that a try if you don't believe it. All right, and number 2 is, remember I said up here in bold, it says Cramer's rule only works when there's one solution. How do we know that there's going to be only one solution? And here's how we can tell. So I'll show you in example number 2 how you can notice that there's not going to be a single solution. So let's start by finding, or trying to find, these three determinants. I say trying to find because you're going to see what happens when we try that. Okay, so we have x, y right here. The x numbers are going to be 6 and negative 1, because negative x means negative 1x. The y numbers are going to be negative 6 and 1. To find the determinant, we'll do 6 times 1, which is 6, minus negative 1 times negative 6 is also 6. 6 minus 6 equals 0, and you can stop right there. This is either going to have infinite or no solutions. And the reason it's going to have one of those two, if you want to find out which one, you can find out using elimination or substitution. So just to recall, if you got something like 6 equals 6, that would be infinite solutions. If you got something like 6 equals 0, that would be no solutions, if you're doing this by elimination or substitution, that is. Okay, why is there going to be no solutions to this? Because when the determinant equals 0, remember that we find x and y by using these formulas right here. And notice what happens if you plug in 0 here or here when you're trying to find x and y, you're going to be dividing by 0. You can't do that. You can test that out at a calculator. Try to divide any number at all by 0, and the calculator is going to give you an error. Okay, so that's where you would stop. As soon as you find out that big D, and it only, by the way, it only works for big D, dx and dy, those can be 0. You're allowed to put a 0 here or here. That would just mean that x itself or y itself equals 0. The only thing that can't be 0 is what you're dividing by. So at that point in the problem, we can just stop, and we know there's not going to be any solutions, or there might be infinite. We know there's not going to be a single solution. Okay, try to pause the video and try out this last one, and when you're ready, press play to see the answer. Okay, so once again, we need to find our three determinants here, and this is the one that we start with, big D. So the x's are going to be 3 and 2, and the y's will be negative 4 and negative 3. And then the determinant of this, 3 times negative 3 is negative 9, minus 2 times negative 4 is negative 8. Negative 9 minus negative 8 is like negative 9 plus 8, which is negative 1. Okay, then we need to find our x determinant. So because we're finding the x, the y's will stay the same as they were before, but the x's get replaced with the answers 15 and 10. Now find the determinant. 15 times negative 3 is negative 45, minus 10 times negative 4. Sorry, that's a diagonal right there. 10 times negative 4 is negative 40. Minus negative 40 is like plus 40, and we're going to get negative 5 as our dx. And then finally we can find our dy. So in this case, because we're finding the y's, the x's will stay the same as they were at the start, 3 and 2, but the y's are going to be replaced with these answers 15 and 10. And now we'll find the determinant. 3 times 10 equals 30, minus 2 times 15 also equals 30. 30 minus 30 is 0, that's okay. We just said at the beginning that only big D can't be 0. It's fine if x, dx or dy equals 0. So x is equal to, sorry, I was trying to use a different color there so we don't confuse with the work that we did. X equals dx over d, and dx was negative 5 and d was negative 1. So that means x equals 5. And y equals dy over d, and dy is equal to 0, and 0 divided by anything is equal to 0. So our final answer here is going to be x comma y will be x equals 5 and y equals 0. And of course we could check those by plugging them back in, and you'll find out that they do in fact work. So that's how you use Cramer rule. That's just another thing to have in your toolkit when you're trying to solve systems of equations. Hopefully it made sense.